Hi everyone, in this video what we will see is Fourier sine and cosine transforms. So what is the Fourier sine and cosine transform? First of all, what is the Fourier sine transform? So the Fourier sine transform of f of x, let me write the definition of that first. Definition. The Fourier sine transform of f of x in 0 less than or equal to x less than or equal to infinity is defined as we denote it by, first of all, fs of f of x instead of f of x, that is square root of 2 by pi integral 0 to infinity f of x into sine sx into dx. So as I was mentioned, so this series of lectures solving is try to solve as many as problems as possible, so I'll not go into how this particular expression has comes right now. And we generally denote this as capital F and then underscore S, meaning the subscript S of S. Okay, so denote that it's a Fourier sine transform. Oh, so now whenever we write such kind of expression, remember we write every time actually we write some Fourier transformation, we write it in pairs, which means if you know what is the transformation, you should also know what is the inverse transformation. Meaning, if we can write f of x in terms of Fourier sine just by writing the same square root of 2 by pi into integral 0 to infinity fs of s into sine sx into dx. Okay, so one is Fourier sine transformation and this is the inverse Fourier sine transforms. So Fourier sine transforms. Okay, now the same thing actually I can write it for the cosine transform as well. Probably what I can do is I can select the complete thing, then copy and paste it and replace something. So copy, go down, sorry. Yeah. So here what I can do is wherever the sine was there, I can change it to cosine and then change it. So here there is sine and here that s can be taken out, and here instead of sine I have to replace with cos, and here and here I think that's all. So the Fourier cosine transform of f of x between this is defined as Fourier cosine transform. So we write fc of f of x, and which is integral 0 to infinity f of x into cosine of sx into dx, and the inverse Fourier cosine transform is defined as f of x equal to square root of 2 pi into integral 0 to infinity Fourier cosine fs into cos of sx into dx. Okay, so that's the definition of Fourier cosine transform. So just a change of notations. Now, in terms of properties of Fourier cosine and Fourier transformation, all the properties what was holded for or what is holding for Fourier transform will work here as well. Meaning the linearity property, whatever we have discussed for Fourier transformation, is going to work here as well. And then the scaling property, that what we have discussed, is going to work for here as well. And the modularization property, modularization property, which we have discussed in the Fourier transformation, is going to work over here as well. Meaning, let me write what is the modularization property here at least. So this was simply Fourier cosine transform of f of x into cos sx is equal to, which seems little new property for you. So this one is 1 by 2 times Fourier cosine transform of s plus a. Remember, you need to find the Fourier cosine transform of s, and then you have to replace by replace s by s plus a. That's what it means. So plus Fourier cosine transform of s minus a, etc. Okay, fine. Good. That's modularization property for cosine, and I think the same thing will work for meaning I can copy this and paste it over here, and then just replace some of the terms to write for sine transform as well. So all that I have to do is just replace this yes, and here writing sine sx. So f of x into sine sx equal to 1 by 2 times fs of s plus a plus fs of s minus a. Okay, that's modularization property, which will work for Fourier sine and cosine transform as well. Okay, so there are two more properties that I can write in this as well, meaning the Fourier cosine of f of x into cos sx, which is equal to this, is also equal to, similarly, we can write Fourier cosine of f of x into sine sx, which is the same thing but minus. So 1 by 2 times Fourier cosine of s plus a minus Fourier cosine of s plus s minus a. So that's my fc of f of x sine sx, and the other one is s of f of x into cos sx, which was 1 by 2 times fs of s plus a minus fs of s minus a. So that's it. So that's the modularization properties. The third one. Suppose if you are hearing some bus or some lorry sound, I'm sorry for that. I'm sitting in a place, my window is little. Yeah, so the change of scale property also will work here as well. So I'm not going to write all of them, so unless it's too necessary. Change of scale property. Refer to the first lecture, I think second lecture, which will talk about the properties of Fourier transformation. Yeah, and this one I needed. I wanted for differentiation of sine and cosine transform. What is this is, suppose if you know what is the sine transform of S and what would be the differentiation of that, meaning if you know the Fourier sine transform of f of x, then if you differentiate this, what you're going to get here is you're going to get Fourier cosine transform of x into f of x. Similarly, if we differentiate Fourier cosine transform of S, I'm sorry, Fourier cosine transform of f of x, then what you will get here is you will get minus Fourier sine transform of x into f of x. So these two are very important properties. So the first one is if you differentiate the Fourier sine transform, you're going to get Fourier cosine transform of x into f of x. The second one is if you differentiate Fourier cosine transform, you're going to get minus Fourier sine transform of x into f of x. So these two are very important. Of course, proof is there in any standard textbook, so please go through it. So as I said, I'm going to solve only the problems. Yeah. the fifth property is, what about Fourier cosine and sine transform of derivatives? Let me write simply 4 derivatives. What do I want was, if you know the Fourier cosine transform of any f, let me write. I don't have to write that, so the notations are already known to you. So if you know what is the Fourier cosine transform of f, then the question was, do you know what is the Fourier cosine transform of f dash of x? And that is simply s into f s of f of x. So if you want to find out the Fourier cosine transform of f dash, that is s into Fourier sine transform of f minus square root of 2 by pi times f of 0. Similarly, if you want to find Fourier sine transform of f dash of x, and that is minus s into Fourier cosine transform of f of x. These two formulas are also very important that we will be using it often. Yeah, just looking at. Make a strong note on it. Okay, fine. Maybe because of this, what you can also do is we can derive for second derivative, third derivative, etc. What I will do is I will simply write only for second derivative. So we will say similarly, if you want to find out the Fourier cosine transform of f double dash of x, and that would be equal to s into Fourier sine transform of f dash of x, right, minus square root of 2 by pi into f dash of 0. Then further, this we know, this just now we have proved it. So this is s into minus s times Fourier cosine transform of f of x minus, of course, this term, so square root of 2 by pi into f dash of 0. And therefore, this is nothing but minus s square Fourier cosine transform of f of x minus square root of 2 by pi into f dash of 0. So that's my Fourier cosine transform of f double dash. Just by applying the Fourier cosine transform of f dash successively twice, you're going to get Fourier cosine transform of f double dash of x. So similarly, you can also find out Fourier sine transform of f double dash of x. You can apply the Fourier sine transform of f double dash of once, and then you will get Fourier cosine, and then apply for Fourier cosine transform of derivative, and you're going to get Fourier sine transform of f double dash, and which is minus s square fs of f of x plus s into square root of s square root of s by square root of 2 by pi into f of 0. So that's the Fourier cosine transform of f double dash of x. Okay, yeah, it's already actually, I think 14 minutes. So what I will do is I'll stop the video at this point, and I will solve the problems on Fourier cosine and transformation in the Fourier sine transformation, cosine transform in the next video. I'll see you guys in the next video. Thank you guys.